Hello everyone, welcome back. And in this video, we'll continue our talk about basic logic operations. In the previous video, we discussed the basic AND operation, and in this video, we will discuss the basic OR operation. So the basic OR instruction is represented with the letter O, and you are required to provide a binary address in front of it. So basically, if we look at our example, this is how the instruction will look like. The instruction itself is represented with the letter O, and you are required to provide an address, a binary address in front of it. Similar to what we did with the basic AND operation. Now, what we want to see is how that instruction is executed and how does it affect the input state, the PLC status word register. For starters, when we discussed the basic AND operation, we said that these two bits, which are the first check bit and the OR bit, decided how the instruction behaves. For the basic OR operation, it is actually quite simpler because the basic OR operation always writes 0 in the OR bit of the status word register. So this instruction, when executed, it will always put 0 regardless of anything in the OR bit, and therefore performance or behavior of this instruction will always depend on the first check bit. And for that, we have only two cases. The first case is when the first check bit is 0 before the instruction is executed. This means that this instruction is the first instruction in a logic block. Therefore, this instruction will have to set the first check bit back to 1 for the instructions that come next to use logic from the current instruction. So our instruction is the first, but as we said, it doesn't have to be the last. And our logic block is started here where FC was put to 1. Now, since it is the first instruction, the value the instruction pushes into the RLO will need to be the same value stored in the address that is passed to the OR instruction. Now, if the first check bit is 1, it means that there was a previous instruction before the OR operation. It means we are not the first instruction, and therefore we will need to use the result of logic operation from the previous instructions. So basically what it will do, it will just keep the first check bit at 1, so this will stay as 1, and it will take the previous value of the result of open operation and OR it with the value of the current address. Let's move to our example to see how this actually works. If we look here, we will see that the addresses we are concerned with in our example lie in memory byte number 1, which is why we put 1 here. And let's suppose for our example that only the second bit is 1. So if the second bit is 1 and we are saying that we are doing the ORing of 3 addresses, we expect the result to be 1. But we will need to look at how we came to that result. Basically, if we look here, the instruction that preceded the first OR instruction was an assignment instruction. As we said before in the previous video, the assignment instruction pushes the value of the first check bit, which is the first bit here, and the fourth bit, which is the OR bit, back to 0. So when this instruction came, it found that the FC was 0. It deduced that it was the first instruction. So what it will have to do, it will just look at the state of the current address. The current address is M1.0. We actually put 0 in that address. We can actually see that by looking at the status bit or the third bit of the status word register. So this address has 0 stored in it. The instruction found that the first check bit was 0 before it deduced that it was the first instruction. So it pushed a value of 0 into the RLO, which is the second bit. That is also shown here. Now let's move to the second instruction. The second instruction works on the address M1.1. And in this address, if we look at the status, we have 1 as our state put in that address. So basically, when this instruction gets executed, it will first look at the first check bit before it. It will see that the first check bit was 1. So logic from the previous instruction will need to be combined with the current address, and therefore 1 is combined with 0. And we get 1 in the result of logic operation here. And then we come to the third instruction. The third instruction looks at the first check bit in the instruction before it, sees that it was 1 before the instruction, and therefore logic from the previous instructions is also needed. Therefore, it will combine the value that is stored currently in that address, which appears here in the status, which is 0, and OR it with the previous value of the result logic operation. And therefore, 0 combined with 1 with an OR operation is 1. Therefore, the result of logic operation remains 1 in this instruction too. Then we come to the assignment instruction. This assignment instruction will first put the first check bit and the OR bit back to 0. Then it will keep the value of the RLO that was used previously. It will be kept as it is. And then what it does is that it moves the value of the RLO to be stored in the address that is passed to the assignment instruction. This value can be seen here to be 1 as the result was 1, and it also appears in the status bit after the instruction is executed. After we discussed how the OR operation works, let's say, what about the OR not operation? Well, basically, an OR not operation is just what it just does. It just reverts the value of the address or uses the reverse of the value of the address before using it for the logic. So let's do some few changes to this example and see how it will work. So basically, let's change all of these instructions to the OR not instruction. And let's see how this changes things. So basically, the value that will be used by this instruction will be the reverse of the address, same for the second and same for the third instruction. So basically, we are ORing the reverse of these addresses, and therefore, if any of them is 0, we expect the result to be 1, which we actually can prove here if we just set the second one to be 0 and keep first one and third one to be 1. and therefore we expect here our result to be 1, because when our instruction comes here, let's say the first instruction, it will store the reverse of this address into the RLO. The second instruction will just combine the previous RLO with the reverse of the current bit, which is 1. So it will combine 0 with 1. Therefore, we will have 1 stored here in the RLO. And then 1 which was stored in the RLO will be combined with the reverse of the current value, which is 1. So 1 combined by 0 with an OR operation is 1. But if all of these addresses take 1, then the reverse of these addresses will all be 0, and therefore our OR instruction will yield 0 as its output. And that does it for the basic OR operation and the OR not operation. In the next video, we will talk about the AND before OR operation, or the OR operation for combining AND logic blocks. Thank you for watching. Please like and sub to the channel.